finding the limit at infinity and at negative infinity. The behavior of functions at large magnitude domain values, whether they be in the positive or in the negative direction. To give an idea of how a function's graph might tend, we look at quotients of polynomial functions. There are three different cases, and we're going to use this to show the technique that we might use to see what a function's doing way out, especially if there's a problem. To give an idea of how a function's graph might tend, we'll look at something of the form an x to the n plus, I'm sent one down to a sub 0 over bm to x to the m plus down to b to the 0. There are three cases. These will be polynomial functions over polynomial functions. The first is where n is larger than m. The second case where n equals m. And the third case where n is less than m. Case 1. We'll find the limit as x approaches negative infinity of 5x to the fourth minus 3x cubed plus 2x squared plus 7x minus 9 over 2x squared minus 9x plus 1. And we will also find the limit as x goes to plus infinity of the same function. The trick is we look at the exponents. Here our largest exponent is 4, here it's 2. We're going to multiply both the numerator and the denominator by 1 over x squared. Or we'll multiply by 1 over x squared divided by 1 over x squared, a form of 1. So let's look at the negative infinity side. 1 over x squared divides into the polynomial in the numerator and into the polynomial in the denominator. Likewise, as x approaches infinity, we use the same trick. What happens as we move the 1 over x squared through the function, we get 5x squared minus 3x plus 2 plus 7 over x minus 9 over x squared over 2 minus 9 over x plus 1 over x squared. And we're going to see the same thing happen over here. What this does is when we're dividing by infinity, we're approaching 0. So we can neglect this term, this term, this term, this term. And we left with 5 times infinity squared minus 3 times infinity plus 2. The infinity squared is going to be the largest. So that's going to tend to infinity. And we're going to divide that by 2. Likewise, over here, we're going to end up with infinity. So the limits are both infinity. Had this been a different case where we would have a negative lead exponent, we might end up with negative infinity. Or where if we would have had a negative multiplier, the same would have been the case. The function tends to continue to rise as the value gets extremely small or goes toward negative infinity. Watch the sign of the lead turn. Case 2. Here we have a tie, the same exponent. So we're going to divide by 1 over x cubed in this case, since we have negative 3x cubed plus 4x squared plus 7x minus 2 over 2x cubed minus 9x plus 1. In fact, the back end of the function really doesn't do anything. Not in the long term, way out. So we can take the limit as x goes to negative infinity and the limit as x goes to infinity of these two functions. Since the x cubed is the largest denominator and the largest numerator exponent, we can run 1 over x cubed through and eliminate all the exponents, both sides here. So we end up with negative 3 plus 4 over x, which is going to tend to 0 when x gets incredibly large, plus 7 over x squared, which also tends to 0, minus 2 over x cubed, which is going to tend to 0, over 2 minus 9 over x squared, another term that will tend to 0, plus 1 over x cubed, which tends to 0. Doesn't matter if it's getting large in a positive or negative sense. If we have an infinity in the denominator, the term is going to tend to 0. And of course, likewise with the second limit. So our limit here is negative 3/2, and our limit here is negative 3/2, and all these zeros, or almost zeros, just don't get involved. So negative 3/2 ends up being a horizontal asymptote in both the positive and the negative directions for this particular function. Case 3, what happens when the denominator is the larger of the two exponents, lead exponents? So we're going to look at the limit x approaches negative infinity of 7x minus 8 over 2x squared minus 3x plus 4, and the limit as x approaches infinity in the same function. We're going to multiply by 1 over x squared over 1 over x squared. Then we're going to end up with, when I bring this through, I'm going to end up with 0 across the numerator and a 2 in the denominator. Let's show that step. It'll end up looking like this. So 0 divided by 2 is 0. Likewise, over here, we're going to end up with 0. So what we will end up with is a horizontal axis asymptote. So the horizontal asymptote, or y equals 0, will become a horizontal asymptote in both the negative and the positive directions. The trick, multiply through by 1 in the form of 1 over x to the whatever power is needed, and take out terms, and you can solve problems. So we get rid of a lot of infinities over infinities and reduce them down to something we can handle.